Hello, this is Mr. Huber. In this lesson, we're going to learn about multiplying radical expressions. If you go back to properties of exponents, 3 squared times 5 squared, that'd be the same as 3 times 5 and then squared. We can do the same thing with radicals. Root 3 times root 5 would be the same as root 3 times 5, which would be the square root of 15. And if we need to do any simplifying, then we might need to do that as well. But the key is the root radical stays the same, and then we multiply the numbers inside the radicals. So if there's anything in front of the radicals, we multiply those as well. Like here, x times y is our general rule. The x and the y would get multiplied together in front of the radical. And this could be any index. So it doesn't have to be a square root. It could be a cube root or any root. We're typically going to deal with square roots in what we're working with. And then we'd multiply the radicands, the numbers inside the radicals. Okay, so multiply the coefficients out in front of the radicals, multiply the radicands that are inside the radicals, and then do any simplifying that's needed. So in number 1, we have the square root of 20 times the square root of 10. Square root of 20 times the square root of 10. And you could simplify first and then multiply, or multiply then simplify. I'm going to multiply this first, and then we'll see it both ways actually. So I would turn this into the square root of 200. And then the square root of 200, I'd want to simplify. That's 100 times 2. So that'd be 10 square root of 2. And we could look at this and say, oh, hey, you know what? I can simplify the square root of 20. That's 4 times 5. That's 2 root 5 times the square root of 10. That'd be 2 square root of 50. And now 50 can be simplified because that's 2 and then root 25 times 2. And when I simplify the square root of 25 and bring that out times 2, that'd be 5 times 2, which would be 10 square root of 2. So it's the same answer, okay? Different process for getting there. It's up to you which one you feel more comfortable with. Some of it could depend on the numbers that are involved and how easy they might or might not be to work with to simplify before or after. All right. So in this problem, I'm going to simplify these first. Okay. So I can simplify the square root of 8. This would be 4 and then root 4 times 2. So that'd be 8 square root of 2. Right. When I take the square root of 4 right here, the square root of 4 is 2 times the 4 that's out in front of there would be 8 root 2. Then times negative 3 root 75. So that'd be times negative 3, and then 75 would be 25 times 3. Now the square root of 25 is 5 times the 3 in front of there would be negative 15 root 3. Okay? And now when I multiply these together, out of 8 times 5, which is 120, I have a negative 120 square root of 6. Square root of 6 can't be simplified anymore, so that would be my final answer. Always at the final answer, make sure that it can't be simplified any further. All right, and number 3 here, we have negative root 17 times 2 root 17. All right, when you see a radical multiplied by itself, the square root of x times the square root of x is going to be x. Okay, if I take the square root of x, anything, times the square root of x, if those are the same, it's always going to come out to x. Okay, the square root of anything times itself will come out to whatever that radicand is. So the square root of 17 times the square root of 17 is 17. So this is negative 2 times 17. So that's negative 34. Okay? A root times itself will always come out to whatever that radicand is. All right, let's look at number 4. I can simplify this first maybe here because 300 times 96. If you do that, then you're going to have some really big number to try and simplify. So this would be 100 times 3. Get the negative 5 there. So the square root of 100 is 10, so it'd be negative 50 root 3. And then times negative 10, and then 96. So again, you might not come up with the biggest perfect square factor right away. That's okay. This is 16 times 6. Maybe you do 4 times something, and that works, and you have to simplify further. That's okay. And so the square root of 16 is 4 times negative 10. It'd be negative 40 root 6. And now when I multiply these together, I'm going to get 200 square root of 18. And we don't want to stop there because the square root of 18 can be simplified. Okay, the square root of 18 can be simplified, right? That's 9 times 2, so it's 200. And then square root of 9 times 2. So square root of 9 is 3 times 200. That's 600 square root of 2. So 600 root 2 is what that would simplify to as a final answer. When you multiply radicals, you multiply the numbers in front of the radicals and you multiply the radicands themselves. You can do that first and then simplify, or again, especially when the numbers are pretty large, it might be good to break them down and then multiply them together. And again, check and see if you have to simplify further. Anytime a radical is multiplied by itself, you will get whatever that radicand is. Keep that in mind. That's very important and useful. All right, before we see some more multiplying with radicals, the first Jesuit university or college in the United States. What do you think it might be? District distinction. A little bit of a clue there. I'll show you some pictures that may or may not help, some iconic buildings in this old university. It is Georgetown University, located in Washington, D.C. That's right, the District of Columbia. It was founded by Bishop John Carroll in 1789 and is the first federally chartered university in the nation. All right, so Georgetown University. All right. Let's look at how we can use the distributive property, which is a form of multiplying. The distributive property works for radical expressions like any other time. Okay, so we want to distribute into parentheses. So I could take this square root of 3 and it will distribute and multiply everything else that's inside the parentheses. So I would have 7 root 18 plus, when I multiply root 3 times root 3, that's going to be 3, so that's plus 15. Right? Anytime you multiply a radical by itself, you will get that number. 5 times square root of 3 times square root of 3 is 3, so 5 times 3 gives me the 15. And now I need to simplify the 7 root 18, that's 7, and then 9 times 2. Okay, so that's going to be 21 root 2 plus 15. And that can't be simplified any further. Those are not like terms or like radicals or anything to be able to add or subtract from one another. So I'd have 21 root 2 plus 15. All right, looking at number 6 here. I'm going to distribute into the parentheses. So I'm going to take negative 2 root 5 and multiply that into the parentheses. So I'm going to have negative 20 root 5. Okay, this 10 multiplies with the negative 2. And then the root 5, there's no radical to multiply with it, just as a root 5. Now I take these and multiply them. Negative 2 times negative 3 is 6, a positive 6. So it's a positive 6, and then root 5 times root 5 is 5. So when I simplify this, I have negative 20 root 5 plus 30, 6 times 5. That would be my final answer there. We're going to continue here with some distributive by distributing the 4 into the parentheses, and we're going to distribute the minus root 6 into the parentheses. So first the 4. 4 times negative 3 is negative 12. And then we take 4 times 11 root 10, that's 44 root 10. And now we're going to distribute the square root of 6. And keep in mind it's a minus square root of 6 times negative 3. So negative times negative is a positive 3 root 6. And then we'd have minus 66 root 60. Then we need to see if we could simplify any of this. Are there any like terms we can add or subtract? Are there any radicals that can be simplified further? Okay, so let's look at that. All right, this can't be simplified anymore. It doesn't have perfect square factors. 6, none of these can be added together. Oh, but down here, square root of 60. The square root of 60 can be simplified. That's 4 times 15. So this is 66 times square root of 4 times 15. So our final answer would be negative 12, nothing to do with that, plus 44 root 10. Plus 3 root 6, and then minus, and then I have 66 times 2, so minus 132 root 15. And that would be my final answer. Those are all simplified as much as possible. None of them can be combined with addition or subtraction. All right, so number 8 here. So again, we're going to distribute. First, we're going to take the 2 root 7, distribute that into the parentheses. So 2 root 7 times 5 root 2 is going to be 10 square root of 14. Then I'd have 2 root 7 times negative 3 root 14. That's negative 6. And then I'm going to leave that as 7 times 14 just for a moment. I'll show you why here in a moment. Okay. Then I can take 2 root 14, multiply that times 5 root 2. That's going to be positive 10 root. I'm going to leave that as 14 times 2. Again, we'll see why in a second. And then here I'm going to turn that into minus 6. And then root 14 times root 14, right? Remember, that's just going to be 14. That's just times 14. Okay, so let's go back to our beginning here. So I have 10 root 14. I can't simplify that anymore. Okay, here, 7 times 14. The reason I left it as 7 times 14, if you want to do this, I can make that 7 times 7 times 2. So now I'd see that I have a pair of 7s here. Okay, and in that next one, I have square root of 14, which is 7 times 2 times 2. And so I can see a pair of 2's there when I go to simplify these. So my 10 root 14 can't be simplified. Then my next one here, I'm going to have a pair of 7's. That's 7 times 7. So I can get 1 7 out. So 6 times 7 would be minus 42 root 2. And then I'd have 2 times 10, so it'd be 20 root 7. And then 6 times 14, remember, square root of 14 times the square root of 14 is just going to be 14. So 6 times 14, that's going to be 84. So minus 84. And that would be my final answer. None of those can be simplified any further. None of them can be added or subtracted from one another. And I've got my final answer there for number 8. All right, let's look now at number 9. We have something squared. One thing you want to be careful of, we are not just distributing the squared into the parentheses. It's not 2 times what's in the parentheses. This means we're multiplying this by itself. Okay, keep that in mind, right? This would be the same as 2 root 11 minus 5 times 2 root 11 minus 5. So when I distribute here, I have 2 root 11 times negative 5. So that's going to be 4 times 11, right? Square root of 11 times square root of 11 is 11. Then I have minus 10 root 11. And then when I distribute here, I'd have minus 10 square root of 11. And then negative 5 times negative 5 is plus 25. So when I go to simplify this, I'm going to have some like terms that I can add or subtract. So I'm going to start out with 4 times 11, that's 44, then minus 20 root 11, because I can add these together, negative 10 minus 10, because they have the same radical, right? Same index and radicand, and I have the plus 25 on the end. And I can add the 44 and 25 to get 69 minus 20 root 11. That'd be my final answer there. So multiplying radicals, multiply the numbers in front of the radicals, multiply the radicands inside them, look at ways you can simplify before and or after you do the multiplication, and distributive property, multiply everything into the parentheses, keeping track of those signs, make sure you're paying attention when you're multiplying positives and negatives, negatives times negatives, and when you multiply a radical by itself, you will get that number. The square root of 11 times the square root of 11 is 11.